right, we're on the record. Okay. All right, everyone. We finished up last time talking about issues with calculating confidence intervals around different regression estimates, R-squared, partial R-squared, some of that stuff. We might jump back in. If we finish up early, I might jump back through and work through some of that. You'll need to do that for this next problem set. Basically, it's just following the formulas put into place, but it'll be important to know kind of where those values are coming from. If we don't get to it today, what I'll do is I'll post a screencast video of just quickly walking through how I'm getting some of those numbers, just so it's clear and it's straight in everybody's head. Okay. But what I want to do now is finish up with talking about some issues of reliability, power, measurement error, types of things that we need to be thinking about in terms of our moderation analyses. What we know is that, hold on real quick. Tara's got stuff going on. Threw me off base. I had to shut that door. Okay. So we've got measurement error issues, and we know that if I have measures that are really, really fuzzy, okay, what I can see is I can start to see evidence of poor internal consistency, test-retest reliability in some of our measures, okay. We know that a primary assumption of our regression models is that we're measuring our predictors without error, but we also know that we actually probably rarely, if ever, achieve that. We're measuring sort of nebulous constructs with measures that are imperfect, and so that we know that we're always violating this assumption of measuring our predictors without error. With our bivariate analyses, we know that if I have error in my measures, if I'm looking at the correlation of X and Y, what that error is going to do, it's adding static into the mix, and it's going to attenuate the estimate of that association. So for any correlation that I run, if I've measured my variables with some level of error, I'm expecting that correlation that I'm observing is smaller than systematically smaller than the population coefficient, just because it includes some additional fuzz. If I'm looking at my multivariate analyses, the impact of error starts to get a little bit more complex. We can get sort of large, small bias that increases, decreases my estimates of effect. A lot of this depends on population correlations that are going on in the background. So with the bivariate analyses, we know that as my measures get less and less precise and more error, what's happening to my observed correlation is it's shrinking and shrinking and shrinking. For multivariate analysis stuff, it starts to get a little bit more complicated. Okay, and so we know this, and we know that this is going on. But what happens when we start looking at our moderation analyses? If I have two variables that I've measured imperfectly, and I have error in both of those measures, as soon as I go through and I take measure 1, scores 1 that are measured with error, scores 2 measured with error, and multiply those two things, now all of a sudden the reliability of my interaction term gets really, really bad really, really fast. And so what we know is that within our interaction models, or within our moderation models, this impact of poor reliability systematically decreases our estimates of the population coefficient. Our interaction terms are getting smaller as our error terms increases. Okay, and why this is complicated and problematic for our moderation analyses is that the reliability of our interaction terms can be shown to be the product of the individual reliabilities of the component terms. Okay, so if I have here the reliability of my interaction term, X times my moderator, the reliability of this term, this variable that I create in my set, is going to be equal to the reliability of my variable X times the reliability of my variable m, okay? And if I have two variables with less than perfect reliability, I'm measuring something that's less than 1 times something that's less than 1. CJ, what happens when I multiply two things that are less than 1? Your mic.
They get smaller.
It gets smaller. It gets smaller really fast, right? Now, this reliability estimate increases to some extent if I have if X and M are correlated with one another, but it's only a little bit. So in general, what I'm finding is that the reliability of my interaction terms starts to very, very quickly get very, very small and questionable as the reliability of my component measure decreases. Okay, and so what we're seeing is that within these moderation models, if I have measurement error in my component terms, the impact on my interactions here and my test of my moderation effect starts to get pretty severe. Okay. Questions about what we're seeing here and why we start to become particularly concerned with the reliability of our measures when we're looking at moderation analyses?
I have a general question.
Yeah.
So we often ask for people to give us reliability estimates of their instruments, but we don't generally ask for reliability of interaction terms.
Yeah.
Is there a way we can do that, or is that just a little bit too much?
Nope. Well, I mean, what I can do is someone gives me a reliability estimate for variable 1 and variable 2. I take the reliability for variable 1, multiply it by the reliability for variable 2, and then I get sort of an estimate of the reliability of my expected reliability of that interaction. So I can calculate it on my own. It's just
the reason we don't just force people to report it?
Yeah, probably because people generally aren't aware that this is an issue because no one goes into this much depth. But if I'm running a moderation analysis for my thesis, I should very much understand that this is an issue, and this is already working against me in terms of my power to detect an effect. Okay, so what we see when we're looking at this association of effect size and power, if we're thinking about regression, our F squared, our partial correlations, these are going to be metrics that are directly associated with my statistical power. These are the metrics that I use to go through and run my power analyses, so on and so forth. Okay, semi-partial correlations, these are nice. These have a nice interpretive value, right? Tomorrow, if I say I have a squared semi-partial correlation of 0.2, what does that mean?
20% of the variability of the unique variability can be accounted for by that variable.
Close, right? Remember, with our semi-partial correlation, sort of the piece of the pie that we're talking about is the total variability, right? So I can say 20% of the total variability in our outcome is, or say X1 uniquely accounts for 20% of the total variability in our outcome after we control for other predictors, right? And that's easy thing to say. So 20% of the total variability in Y is unique to this predictor. That's a nice thing. I can think about and understand that, right? Problem is their semi-partial correlations don't have a direct association with power, okay? So within a context of our regression, if I have some effect in my model that accounts for 1% of the variability in Y, what I'm going to find is the actual power of that effect in my model starts to depend on how much of the total variability in my outcome I've actually gone through and accounted for. Okay, so if I have some variable in my model that uniquely accounts for 1% of the total variability in my outcome, depending on how much of the variability of what my R-squared value is, the power of that of my study to detect that effect starts to change around. Okay, so for example, if I'm just looking at my measure and effect for an interaction that's accounting for 1% of the variability in Y, that effect size is going to be greater when my lower order effects account for 80% of the total variability of my outcome, as opposed to when my lower order effects only account for 10% of my outcome. Okay. Again, we had talked about this before. Our tests of our individual predictors are much, much more powerful if we're doing a good job of accounting for total variability in my outcome. Okay. And Sean, do you remember why this is?
Because of the covariance between the two terms.
Covariance, yeah, it starts to, but from a conceptual standpoint, if I'm accounting for 80% of the variability in my outcome, or I'm accounting for 10% of the variability in my outcome, what's the difference there? Which model is predicting things better? 80. And if I'm predicting 80% of the variability in my outcome, what's the error variability in my outcome? 20, right? And if I'm accounting for, if my model accounts for 10% of the variability in my outcome, what's the error variability?
90.
Right? And where does that error variability generally go in my tests of statistical significance? Generally pulled into my standard error and my denominator, right? If my denominator, my test statistic is a lot bigger, what happens to my test statistic? Gets smaller, right? If I have less error, right, it's just a more precise estimate, right? And so what we find if we're looking at systematic effects, in this case, right, my squared semi-partial correlation is still 1%. My variable uniquely accounts for 1% of the total variability in the outcome, irrespective of whether or not my total model accounts for my R squared for my model is 80% or 10%. But what we're going to see with 80% of my variance explain this 1% increase in residual variance, this gives me an F squared of 0.05. With only 10%, my resulting F squared is 0.01, right? And so what ends up happening if I want to go through and have a good test of a moderation model, right? And this is important when you're planning theses, dissertations, projects, and things like that. If my analyses are relevant to sort of these interaction effects, it's in your best interest to go through and try to find variables that are going to be unrelated to your primary variable as of interest, but that still are accounting for stuff going on in my outcome, okay? So, Chris C., for your thesis, what are you interested in looking at? What's your outcome variable?
It's kind of a qualitative study. So
Oh, gross. I'm going to kick you out of this class.
Yeah.
Okay, no, joking. So tell me, so what might be something that you would be interested in looking at?
Dyadic coping.
Okay, so let's say coping, right? Sort of coping stuff, right? And so I've got variable 1, variable 2, and some interaction that I'm interested in looking at, right? But what it would do is it would probably be in my best interest when I'm planning that study to look through the literature and say, what other things are related to coping? Not things that are overlapping with the effects that I'm actually interested in looking at, but things that are orthogonal. So outside of the stuff that I'm interested in looking at, what other types of things do we know from the literature start to account for variability in coping? And let's go ahead and include those. Let's measure those, include those in the model, because as my R squared starts to get bigger and bigger and bigger, what happens to my error in my model? It gets smaller and smaller and smaller, it gives me a more powerful test. So maybe my interaction is only accounting for 1% of the total variability in my outcome. But if I've got an R squared of 80, or an R squared of 0.8, my effect is much, much larger than if my R squared for my model is 0.1. Okay? So just something to think about in terms of planning. Having a good model and doing a good job of accounting for the things that we're trying to account for helps us in terms of power with stuff. Okay? So we did this, and I think I had mentioned with Layla's thesis is we went through, and she's interested in interpersonal functioning and looking at empathy and things along those lines and some stuff going on there, right? But the capacity to get a large enough sample to adequately test a moderation analysis, these require a big sample. So what we did is say, okay, so we're interested in empathy and PTSD. What other things might account for variability in interpersonal functioning that aren't related to PTSD or empathy, right? And so there was things like personality, some attachment stuff, some other things that she expected to be relatively independent of the primary variables of interest, but stuff that's still going through and accounting for differences that we see across people in terms of interpersonal functioning. Okay. People kind of get the idea behind this. Okay, so if I'm looking at effect sizes for interpretive norms, again, there's no interpretive norms benchmarks for semi-partial correlation because those kind of fluctuate depending on what my overall model is accounting for. But the nice thing about our partial correlation, kind of less of a straightforward interpretation of our partial correlation, but partial correlations adhere to sort of general rough benchmarks from small, medium, large, and our F-squared statistics. These are nice. This is what go directly into power analyses. Same type of thing. We can convert our partial correlation back into F-squareds. But what we can do is we can start to benchmark sort of magnitude of effect here. Okay. So, tying all this together, if I've got a case where my conditional effect and my moderator are uncorrelated, okay, and my lower order effects count for 50% of the total variability in my outcome. So just my first order effects, R squared for that is 0.5. So if we would have ran this in a hierarchical regression model where we put all of our first order effects in, our R squared in this example would be 0.5. Okay. The sample that I would need to achieve adequate power for small, medium, and large interaction effects are going to be as follows. So let's say I have my interaction of X and M, right, is consistent with a large effect in the population. So the population effect is quite large, right? If the reliability of my interaction term is perfect, that means if I've measured my conditional effect or my X perfectly without error and my Y perfectly, or my moderator perfectly without error, then my observed effect in my data is equal to population effect, 0.35, and I need 26 people in my sample to detect this. Okay? But let's say my interaction is not perfect, or my reliability isn't perfect. Let's say I got reliability, it's not 1, but it's 0.8. Do we generally identify 0.8 as a reasonable level of reliability? Yeah, 0.8 is generally like, oh, I've got good reliability, excellent reliability at 0.80, right? But what that does is if my population effect is 0.35, that unreliability in my interaction term shrinks that down to about, functionally, 0.11, and now all of a sudden I need 75 people to detect that effect. If my reliability in my interaction term drops down to 0.7, takes my population effect from 0.35, drops it down to functionally an effect of 0.06, and now I need 127 people. So dropping the reliability of my interaction term from perfect to 0.7 adds 100 people to my sample that I need to go through in order to adequately detect this effect. Okay. Let's say I'm working with a medium effect. Okay. So I've got an interaction that in the population is associated with effect size of 0.15. With perfect reliability, my observed effect is 0.15. I need 55 people. I drop it down to 0.80. My population, or my observed effect, goes from equal to population down to 0.05. I need 153.7. Now I'm up to a sample of 275. If I'm looking for a small effect, I got a population effect, and I'm looking for an interaction in the population that's small, F squared 0.02. If I measure my variables with perfect reliability, I need close to 400 people in order to detect this effect. Okay. If I drop down to 0.8, now I need over 1,000. If I drop down to 0.7, I'm up to getting close to 1,800 people in order to adequately test this effect. Okay. And so if we're thinking about what reliabilities that I need to see in my just my straight individual variables in order to achieve a reliability for my interaction of 0.8, if I take 0.89 and multiply it by 0.89, I get an interaction reliability of 0.80. Okay, so Chris, it seems like you've gone through and it sort of been attending to reliability estimates in data. What would you see if you saw a reliability estimate of 0.89?
I think that would be pretty good.
Yeah, that's pretty good, right? We're super excited about that, right? But as soon as I multiply that by another measure that has excellent reliability, now all of a sudden I'm down to 0.8, and I'm sort of working at this middle point right here, right? And Chris M, so I'm saying I'm looking for an interaction. In social sciences, what's the magnitude of our interaction effects? Are these big effects?
Or no, you're generally going to see them pretty small.
Pretty small, right? So if you're looking at running an analysis that has where you're looking at a moderation effect, this down here, this is what you're looking at, right? Unless you have some evidence, right, from existing literature that this interaction is massive, this is probably where you're looking at. And now all of a sudden, the sample that I need to reasonably power this, particularly if I have ugly measures that aren't super reliable, it's starting to get out of control with things, okay? Now, there's not a ton that we can do about this, right? Like I said, we're behavioral scientists. Our constructs are fuzzy. Our measures are even more fuzzy. But as you're going through and you're selecting variables for your research, it starts to become important that you're thinking about, is this a validated measure? Is there a measure of good? Do I have evidence that this is a valid and reliable measure? Because if I don't, if I just make up my own scales, or I'm lazy and I just choose stuff that's happen to be on hand that has questionable reliability, validity, what I'm doing is I'm basically sinking my opportunity to detect defects, even if they should be there and they should be detected. Okay.
I have a quick question, Josh.
Yeah.
Is there a point at which you can overload your model? Like, to jump back to the last slide? You have too many lower order effects like fit into the model.
Yeah. So this is a thing that people often get confused by is, if I have a model with 15 variables, sort of what does that do to my power? The number of variables in your model actually has a pretty minimal impact on your overall power. This is one of the things in psychological science, right? With the stuff that we do, if I saw a regression model with like 10 predictors, I'd be like, wow, that's a lot of predictors in that model, right? But in other areas, Sean, talking with Sasha about how in econ and finance and marketing, some of the types of models that people will have there, or in sociology or things like that, thousands of variables in those models. Now the samples are a lot larger, right? But proportionally, a whole lot more variables in there than sort of what we would typically see with a standard model in psychology. So I wouldn't be worried necessarily so much about the number of predictors in there. What I would be concerned about for us, Chris, is the overlap. Okay, because our measures start to have a ton of overlap, right? And if I'm interested in the unique effect of predictor X, but I throw in A, B, C, D, E, F, and G that are all highly, highly overlapping and correlated, what does that do to sort of the amount of variability that now is eligible to predict anything? It gets really small, right? So in clinical stuff, the thing about this is what happens to my effective interest for clinical people if I go through and I throw a BDI into my model?
It can, because it's just like broad, it can...
Yeah, it friggin' wipes everything out. Like, it just like everything, like sort of, because it's just a model of just general negative affectivity and distress, right? It just sucks out all the air in the room, and there's really nothing left over to predict after we've sort of pulled out negative affectivity, right? And so this is the thing with Layla's project. We had to be careful. It's not just like, oh, let's throw in, oh, well, I want to know, I'm interested in PTSD and empathy in predicting interpersonal functioning, right? Well, let's throw in state trait anxiety, depression, neuroticism, so on and so forth in there. Is that a good idea? No. It's going to drive up my R squared, right? I'm going to do a lot better job of accounting for variability in my outcome. What it's going to do is I'm going to go through and I'm going to sink any effect that I'm actually interested in, right? So think about and remember that from a classic standpoint of regression, our best regression models are those models that do a nice job of accounting for variability in outcome with a set of unique predictors that are non-overlapping with one another. Now, we can't not have predictors that overlap with one another because we're, again, working with psychology. Everything overlaps to a little bit, but we don't want to have stuff that's just stacked on top of one another, okay? And there's some recent literature I got from a student who used to work in my lab talking about how sort of the argument is, well, if this predicts something above and beyond general negative affectivity depression, then it means something, right? Then it's really contributing. But there's problems with that statistically in terms of what we can interpret and draw from that stuff. So best case scenario is for these types of models. And if it's something that you're going to do data collection for, do some homework. Think about what accounts for, based on theory and research, what accounts for variability in my outcome, and what are some measures I might take that are getting at pieces of the pie that are separate from what I'm wanting to take a look at, that's going to increase your R squared. It's going to decrease your overall error, and it's going to increase the power of your effects. Okay, so probably not, hey, let's just throw everything that I could possibly look at in and see what turns out, but being careful and thoughtful about what you might include as covariates. And so again, Layla's thesis got cut short because it was a lab-based project, ended up with like 95 people, but we still got signals on a couple of different interactions within that set that go away if those covariates aren't in there. And the covariates aren't necessarily related to the main effect or the effects of interest, but what it's doing is it's reducing that error variability to get a stronger test of our effects. Okay. Questions about this?
Quick question.
Yeah.
I know that normally the acceptable standard is reliability of 0.7. But if you have two variables or two constructs with a reliability of 0.8,
yeah,
so you will have in the interaction term a combined reliability of 0.64,
yeah,
which is not going to be acceptable.
yeah.
So how do you deal with that?
I don't know, right? Like, that's the thing. And this is, Ignacio, the difficulty with relying on sort of these rules of thumb, right? Like, oh, well, 0.7 is acceptable reliability for always and forever. Well, I don't know. It kind of depends on what I'm looking at and what I'm trying to do, right? Because if I've got two variables with reliability of estimates of 0.7, what's the reliability of my interaction term?
149.
Yeah. And is that good? No, I'm pretty bummed about that, right? And so I don't know what we can do, right? Now, in terms of, this starts to get into a methodological issue. Chris C complained in his last assignment, we don't get enough into methodological issues in this class. No, he wasn't complaining about that. But the thing is this starts to become a methods issue, right? And thinking about what am I doing in my study to help increase the reliability of my methods, right? So if I can have good experimental controls that sort of increase the likelihood of assessments being administered properly and people paying attention, and everybody's doing the same thing, whatever I can do to reduce the static of my measurement is going to be helpful in terms of power for my tests. Other questions? Okay. So, some advanced stuff in Aiken and West, looking at intersections of simple slopes, if that's of interest, specific comparisons, three-way interactions. This is something that may come up for some of you in terms of theses and dissertations and things like that. How do we tease out three-way interactions? Hierarchical multiplicative models, sort of arguments for step-up versus step-down procedures. All this stuff is in Aiken and West. So again, sort of tying all this stuff with moderation together, thinking about moderation reflecting a process where you have some third variable that's starting to change the magnitude or direction of some association between X and Y. Okay, we like to center our multiplicative terms, so it helps with interpretation, and it's a much better approach, what we've done here, than median splitting or dichotomizing anything. That's pretty terrible, and probably there's really no good argument for doing that when we have these tools available to us. We can include standardized solutions, categorical predictors. Remember, when we're talking about, in the presence of interaction effects, our first order effects aren't main effects anymore. These are conditional effects. The association of X on Y depends on some third variable, right? So if someone says, hey, what's the association of X and Y in the presence of an interaction term? What's my answer?
It depends.
Yeah, it depends. I don't know. Tell me what this the level of this other measure is, because that affects sort of the strength or direction of this association. Okay, and so again, we should always be concerned with our measurement and our reliability and our measurement error. Our assumption of our model is that we've measured things perfectly without error. We know that that doesn't happen, and we just kind of deal with it. But as soon as we transition now over into interactive models with moderation effects, now all of a sudden that reliability issue starts to become really important, because the reliability of my interaction effect decreases multiplicatively as my reliabilities for my base components get smaller and smaller. Okay. All right. Some formulas, things like that, if you're interested in nuts and bolts. But that's it. Okay. Any questions about moderation stuff? Cool. All right. Let's go through. Let's take a break. Come back in 10, and we'll jump into mediation. All right. Cool. All right. What we're going to do now is... Oh, cripes. All right. There we go. Gonna switch over to mediation. All right. Show of hands, and I don't have you all on my screen at once. Has anybody gone through, worked with intervening variable models or mediation models previously? Have any sort of exposure to this? So Chris, yeah. Anybody else? Ignacio, a little bit. Okay. So classically what we would call these are mediational models or mediation analyses. There's a lot of stuff that's a little bit tricky in terms of how we're thinking about that, and we're going to talk about how to think about these processes and these analyses and how we would go through and interpret these. Personally, I wouldn't. I've done these types of projects before. So I tend to prefer presenting these as intervening variable models. The word mediation has a lot of baggage with it, and sort of makes people really upset about this type of thing. Mediation is kind of the traditional way we talk about things, but sort of I'll go back and forth, talk about intervening variables. Intervening variable models is a way to sort of soften it up for people who get sort of bent out of shape about some of this stuff. Okay. So, if we're talking about, so here what we'll do, we'll go through, run over general framework, talk about some classic approaches to testing some of these hypotheses, work through the limitations, and then we're going to talk more about analyses of indirect effects, which is generally, I think, maybe a more useful way to think about some of these things. Okay, so again, if we're thinking about going back to our standard linear regressions, right? Again, our regression models are nice, providing an assessment of the unique association between some predictor or explanatory variable and some level and some outcome. But again, as we talked about when we kicked off moderation, coefficients in our linear regressions limited in what they're able to say about the specific nature between x and y. Okay, they can say, yep, within these data, controlling for these variables, there appears to be a unique association. But after a while, that's not going to be super exciting, right? If I see that PTSD and social support are associated in study after study after study, I'm not super interested in sort of maybe whether or not there's a unique association there. What I want to do is take this to the next step, and maybe the next step is asking about what factors that might account for, maybe even cause, if we want to use this term, some association between x and y. Okay, so here, what I'm asking is, I know that x and y demonstrate an association. If I measure x, if I measure y, I know those two things are going to be related to one another. But what I might want to be what I might be interested in is why. What's the nature of that association? Why are those two things connected to one another? Okay, and if this is the question that we're asking, we're talking about what we would classically refer to as mediation. Okay, if we talk about mediation within behavioral sciences, we're talking about some process where we have some external variable either causes or facilitates an association between x and y. Okay, so within this framework, if we're talking about a mediator is any variable that accounts for the association between x and some corresponding outcome. All right. So if we go through and we draw a classic diagram of mediation, this is what these often look like. I've got x, and I know x is related to y. But the reason that x is related to y is because of something here. Okay? And this is the test. What we want to see is if I account for this mediator, are x and y still related to one another? Okay? And if this is the mechanism between x and y, right? What we've done is we've established sort of this mediational path. So, Chris Sam, if we're going through, I know that binge eating is associated with increased weight body mass, right? What's the mediator of that relationship?
The binge eating can explain the relationship between.
Well, I've got binge eating is x, weight gain or sort of obesity maybe is y. What's the mediator there?
You didn't say a third variable. I don't know.
Well, if I eat too much and I get and my weight increases, what's
Maybe my dietary intake.
Yeah, it's caloric intake, right? And so we know that people who, well, I don't know this, I'm guessing, sort of maybe that, so people who have binge eating disorder may show higher levels of weight, right? The mediator in this case is going to be caloric intake, right? And so thinking about, I mean, that's sort of a very obvious example, but just to try and give you an idea of how this plays out, okay? Now, what will happen sometimes, and in the articles that we've assigned, people start to talk about mediators and moderators interchangeably, right? So anytime I see someone in a paper say, what we're going to do is we're going to do this and explore mediators and moderators, I say, whoa, let's pump the brakes here, because those are completely different things in terms of sort of processes and sort of theoretical relations between stuff, okay? Alicia, if I'm talking about a moderator, right? Here's my diagram of my moderator. How do moderators work?
The moderators are, they don't like cause a difference, but they could be contributing to a difference between x and y.
Right. So our moderator is going to be something that changes the nature of the association. It's going to make, a moderator is some third variable that makes this association stronger, weaker, flips around the direction, right? X doesn't cause the moderator. The moderator is just something out there that changes the nature of X and Y. If I'm talking about a mediator, I'm talking about a mechanism. I'm talking about some variable, some third variable that accounts for the association between X and Y. This is why these two things are related, okay? So I want to be very, very clear in terms of when we're talking about things, sort of mediation and moderation, conceptually talking about two different things. Now, whether or not something's a mediator or moderator can be hard to sort of tease apart. In some cases, it might be a little bit of both. But from a very sort of conceptual standpoint, wanting to make sure that we're clear on sort of the difference between these two. Questions on this? Okay. So if I'm looking at some specific hypotheses here, right? CJ, so my hypothesis is that attitudes are related to behavior because of behavioral intention, right? And this makes some sense within the context of theory, right? My attitudes about things and my behaviors sort of are mediated because this behavioral intention causes these two things to be related. Once I account for that, are attitudes and behaviors associated with one another? Probably not, right? Or at the very least, that link starts to decrease considerably, right? Because I've identified the mechanism of that association, okay? For clinical people, positive effects of EMDR, eye movement desensitization, reorganization, so on sort of functional outcomes, right? Mediated by non-directive exposure, right? The mechanism, the proposed mechanism of this intervention, and for people who don't know or are unfamiliar, this is trauma-focused treatment where what we're doing is having people talk about and explain and sort of go through and describe their trauma in detail while maybe tracking a finger, right? Or some other thing, right? And the argument is that eye movement helps to reorganize and reprocess that trauma memory. Well, probably what's happening is you're just engaging someone in an exposure exercise, and that's what's causing those things to go down. The proposed mediator, and the criticism of this from a scientific standpoint, is the proposed mediator isn't actually the proposed mediator, it's something different, okay? So people see the difference between mediators and moderators, how we're going through and describing these two models. Okay. So from a classic approach to mediation, classic approach to teasing some of this apart is what commonly known as a causal step approach. This has been around for a while. A paper by Judd and Kenny kind of started to pull this together. And what Judd and Kenny did in terms of a contribution was start to try and establish certain conditions under which we might start to infer a mediated effect. Okay. And what Judd and Kenny proposed was that what we needed to see first was that X demonstrates some association with Y. Okay. If X isn't associated with Y, can we have a mediated relationship? What do you think, Nick?
Sure.
If X isn't related to Y, does it make sense to talk about a mediator of that association?
Oh, no.
Yeah. It's hard, right? In terms of a logical standpoint, in order for me to start to talk about some interaction or some mechanism of the association between X and Y, I sort of need X and Y to be related in the first place, right? Or at least have some evidence that sort of X and Y should be associated with one another, right? So for the Judd and Kenny approach, step one, we need to demonstrate that X is associated with Y, right? And then two, what Judd and Kenny said, that each variable in the causal chain impacts the variable that follows when all other prior variables are controlled, okay? So here, this is a roundabout way of saying, if we're thinking about this temporally, and I measure X at time 1 and Y at a later time point, if this is a mediator, when does the mediator need to be assessed tomorrow?
Can you say that again, please?
Yeah. If X is being measured today and Y is measured next week, when should I probably measure my mediator?
Before next week.
Yeah, sometime in between, right? And so if I regress my mediator onto my X, I should see an association. And if I regress Y onto my mediator and my X, I should see an association here, Okay, so what Judd and Kenny are saying is that in this chain of associations, each variable needs to impact the one that follows it when everything else to the left side is accounted for. Okay, and then what Judd and Kenny said is that once I account for this mediator, X no longer demonstrates an association with Y. Okay, so within this model, X and Y are related. So this C path, this is just if I look at the bivariate relation between X and Y, X is associated with Y. This tells me that I have some association that I can then account for, right? X and Y are related to one another, so what I'm interested in looking at is the mechanism, right? So what I do is I take a look and I take a look at the relation between my mediator and my X. This is my A path. Because I want to see if this is a mediator, then I need X to cause the mediator and the mediator then to cause X, or then to cause Y, right? So I need to see an A path here. And then I also need to see that the mediator directly is associated with my outcome when I control for X, right? So I need to see this B path. And then, once I've looked at and regressed Y onto both my mediator and X, Sean, what happens to this C prime path right here?
If it's fully mediated, it goes away.
It goes away, right? And so, Chris M., if my hypothesis is, I'm not overly, if sort of those people around me aren't familiar with basically how the body works, and I say, well, binge eating is associated with increased weight gain because of increased caloric intake, right? If I account for caloric intake, should there be any association between binge eating and outcome? No, it goes away, right? Because I've gone through and I've sort of pulled the pin that causes those two things to be related. And so once I've accounted for that, that C prime goes functionally to 0. Yeah.
For the record, I actually don't know that increased caloric intake mediates the relationship. I was like trying to look this up while we were talking.
It's a heuristic. It sort of makes sort of hold on. How about this? How about this? We see that drowning deaths are associated with pavement temperature. See a strong correlation between temperature of the pavement and drowning deaths, right? So if I go through and I put a temperature, a thermometer on the pavement outside, I see that is robustly across the nation associated with drowning deaths, right?
By increased swimming behavior.
Exactly. There we go. So if we count for, hey, it gets warmer, there's nothing about pavement temperature that necessarily causes people to drown. But what ends up happening, we've got a spurious correlation between two things that's accounted for by increased temperature, swimming behavior, things along those lines. Okay. All right. So this is Judd and Kenny's original proposition. But there are some issues with this, and sort of Barron and Kenny go through and update this in a later paper, and they say, all right, what we need to do is if we're demonstrating a mediated effect, what we need to do is we need to say that, yes, X demonstrates some association with Y to begin with. Otherwise, we don't have a moderation or an association to mediate, okay? And then we need to see that X demonstrates a significant association with my mediator. If this is a mechanism, if X and Y are related because X causes the mediator, which then causes Y, we need to find an effect here, right? So we need to find that A path. And then what we need to see is we need to see that a mediator directly is related to Y. So this B path needs to be existing. And then if both A and B are controlled, this C prime path, so the residual association between X and Y after we account for that mediator, has to be reduced to some extent with the strongest evidence for mediation occurring if that C prime path has fallen to 0. So, Chris C., what's the main difference between sort of the original Judd and Kenny framework and sort of the Barron-Kenny causal effects approach here?
So with the Barron-Kenny, C prime doesn't have to get to completely 0.
Mm-hmm. Exactly. So originally, Judd and Kenny are saying that this C prime path has to go away, right? If I've got true evidence or strong evidence of mediation, X and Y are no longer demonstrating an association once we control for this. Barron and Kenny came in and they said, well, maybe it doesn't have to be exactly 0, but we at least need to see that the coefficient in my estimate of C prime has to show some meaningful reduction when we account for that mediator. Questions about the basic conceptual framework?
Could you potentially have two mediators in the same model?
Yeah, we absolutely can. And so hold on to that for a moment, CJ. We'll get to that.
We may also get to this, but my understanding of like the beef with mediation is that like most people think like X should be first and then Y should be second, and that like that cross-sectional mediation like isn't a thing. Where do you fall on that?
Yeah. Well, I mean, I think it's like anything. It's a strength of evidence thing, right? So a strong test of a true mediation hypothesis, you probably should have longitudinal data where we can go through, as Tamara noted, right? If I'm sort of saying X holds a predictive relationship with Y, I should probably measure the mediator somewhere in between there, right? In order to go through and say, sort of establish that causal step or that causal chain. That's a much stronger evidence for my hypothesized effect. Now, the problem with running these types of analyses within cross-sectional data, right? If I'm looking at the relation between PTSD, depression, and social support, all measured at time 1, and I say PTSD is associated with social support because of depression, right? And I say this is social support, this is PTSD, and this is depression, and I find an indirect effect here, right? But who's to say, well, what if I just throw these in a bag and shake them around, right? Maybe PTSD or depression is related to social support through PTSD, right? Or maybe PTSD is related to depression through social support. If I can interchange these variables in any model that makes perfect sense, I start to lose the value in sort of arguments for why this is exactly sort of the way it is, right? So I'm not a stickler for, it has to be longitudinal data, but I would say you got to give me a convincing evidence for why I can't just scramble this around, create a new model, and that makes just as much sense as the one that you've proposed to me here.
Just like theoretically, like this one has to be here, this one has to be here.
Yep, exactly. Exactly, right? If you can give me a strong argument based on theory and previous research why this is the way this model should look, perfect, right? And why the other stuff doesn't make sense, good, right? But that's the problem with cross-sectional data is, if I've measured X at time 1 and Y at time 2, it doesn't make sense to say Y1 or Y caused X because we don't have Back to the Future machines, at least to my knowledge. To the author's knowledge, no one has a time machine to go through, right? But it starts to become harder to make a strong argument for why I should take your intervening variable model seriously, unless you give me a strong reason for this is why specifically we set it up that way.
Okay, cool.
Yeah. So, assumption of our causal models. We're assuming, sort of within this framework, we're assuming that X causes Y and not vice versa, okay? We're assuming that our mediator here precedes Y in time, right? So this mediator was measured before we measured our outcome, and also that our mediator is a plausible agent of Y, right? Ignacio, you had mentioned at some point talking about third variable questions and omitted variable bias and things along those lines. This starts to become important because our mediator can't be just some random thing, right? It needs to be theoretically, conceptually, yes, this makes sense that this could in fact be a plausible mechanism of Y, right? And then 3, getting down, and this is specifically your omitted variable bias issue, we're assuming that the association of X and Y is not the product of some other unmeasured construct or process, right? And CJ, this gets to your question about could there be multiple mediators? Well, yeah, there are and probably are, right? The issue is that what this, in sort of the causal steps approach, and sort of this is getting back kind of at Chris, what you were saying, traditional would say we need to say that these things are laid out in time, right? So that we have X at time 1, mediator at time 2, Y at time 3. the mediator needs to be some reasonable agent and some causal factor of y, and that this whole thing isn't due to some obvious variable that we've omitted from the analyses, so that we've missed the boat on something. That would be a model specification issue. People kind of get sort of the idea behind, sort of the logic behind this. Okay. And so the math and the analyses is not difficult. The logic is what you want to make sure that you're squared away on. Okay. So, when we're thinking about this causal steps approach from Barron and Kenny, what makes it unique, as Chris noted, is that it recognizes the potential for partial mediation. Okay. Given our field, CJ, it's implausible that we have some outcome that's completely dependent on one single mechanism, right? If I count for this one thing, this is the one thing that accounts for everything, all the variability in my outcome, right? And so what's probably more likely is we've got multiple mechanisms going in, driving some sort of outcome, okay? And so Barron and Kenny is nice because as opposed to the original Judd and Kenny, where the C prime has to be, or C has to completely go away, Barron and Kenny says, well, it just has to be reduced to some degree. Okay? And so we're thinking about why we might see that C prime not completely go to zero. There's a number of different things that we can think about conceptually that could cause this, right? We could find that X has some direct effect on Y and an indirect effect on Y. All right. So if we say, actually, there. Look at that. That's a verse that impromptu, in-stream change of the slide, right? So what we might find is that X has both a direct effect on Y and an indirect effect on Y through the mediator, right? So not only do I have a mediated path, even once we account for that mediator, X still has some direct, X and Y are related because X causes Y. Like that's sort of what's going on, right? So if we have a combination of both a direct and indirect path, what we might see is partial mediation where this C path doesn't completely go away. Okay. We also might find that the relation between X and Y is mediated by several processor constructs, but I've only measured a couple of them, right? So I see that, yeah, we see a reduction from C to C prime once I account for my mediator, but I still have an effect here because there's 2 or 3 other processes that are accounting for this relationship. And because those aren't in the model, it still looks like X is still related to Y to some degree because we've omitted these other predictors. Okay. We might also see a partial mediation because the indirect effect of X on Y isn't constant for all members of the population. Okay, so for some subset of my population, I've got a strong intervening variable, indirect path here. But for other parts of my population, I'm not seeing such a strong effect, right? So let's say tomorrow, if we're looking at cultural differences in some type of thing, maybe for majority white Western society, we're saying, yep, this is a sort of thing that an intervening variable in the relation of these two things in terms of relationship formation or sort of management or emotion regulation or something along those lines. But for a decent chunk of my sample, it doesn't, right? And so there's something else going on here that's not being accounted for this. What we might see there is this is going to be a misspecification due to some moderation of my mediated path. So this indirect effect of X on Y through my mediator changes depending on who I'm talking about, right? And what we would identify this as what we might call this, you hear this referred to as moderated mediation or conditional indirect effects. That's a phrase Hayes has coined and sort of talked about. I think it's probably a more flexible way to go through and think about this, right? So here, our mediation is moderated by some fourth variable now that changes the strength of this indirect path. Okay. Last thing, we can have measurement error in our mediator that results in an underestimation of its sort of paths here. So I've got a kind of a terrible measure of my mediator. And so it's attenuated A and it's attenuated B, which attenuates the overall indirect path so that there's still some more stuff going on. Again, partial mediation, if it's due to measurement error, it's another case of model misspecification because I haven't measured my mediator appropriately and I'm missing a lot of stuff. But for all of these reasons, we can start to see so this idea that we need to have this original C path reduced completely to 0 is probably not reasonable given the types of stuff that we're doing. Okay. Questions on this? Okay. Mediation's, show of hands, mediation's a little easier to follow than moderation, right? Just kind of makes logic sense, like X leads to Y, X leads to Z type of stuff here. Okay. All right. So we've got kind of the framework. We're comfortable with this. How do we go through and evaluate this? Okay. From a traditional causal analysis, causal steps analyses, first thing I want to do is I'm going to regress Y onto X to establish some effect to be mediated. Okay. This is my C path. What I'm going to do is I'm going to take a look at Y, regress that onto X, and make sure that I have an association going on here. Okay. Then what I'm going to do is I'm going to regress my mediator onto X to determine a relation between the mediator, right? This is my A path. So I go through and I do that. Then what I'm going to do is I'm going to regress Y onto X and my mediator both to establish a unique association between my outcome and then my mediator above and beyond residual effects of X here, okay? This is my B path. Okay. What I can't do and what I will sometimes mistake people will make sometimes is like, well, I'm just going to regress Y onto my mediator, right? Well, what we need to do is we need to account for the effect of X here as well, right? So when we regress Y onto our mediator and X, what we do is we get an effect of B controlling for that original effect of X. Okay. And so then what I needed to do is I need to determine from a classic causal steps approach whether or not that mediator completely, or my mediating variable completely eliminates the relation of X and Y through a test of C prime right here. Okay, if I don't have any evidence of a unique effect in my C prime coefficient, then I would traditionally identify that as evidence of full mediation. If I have C that still have some evidence of C prime, it's still kind of there, what I might consider that as evidence for a potential partial mediation effect. People comfortable with kind of the walkthrough how we go through and do this? Okay. So let's say that C was there and C prime still is there. How do I go through and detect whether or not we've got enough of a change to go through and say, oh, I have some evidence of perhaps a partial mediated effect, okay? So for my measure of mediation, in a classic causal steps approach, we would define my mediating effect as the absolute reduction in C to C prime, okay? So here, if this is C, this is C prime, the literal difference between C and C prime in my unstandardized effect is my measure of the indirect effect. That's my measure of my mediation. Now, so traditionally what we would call C to C, C minus C prime, we'd identify that as my mediated effect. We can also talk about this, and probably should be talking about this a little bit more flexibly. The difference in my C to my C prime path is going to be mathematically equivalent to the product of my A and my B path, okay? And what's, I would argue, better about this is instead of talking about the reduction from C to C prime, I can talk about this as just the indirect path of A times B. Now, in a simple mediation, A path, your coefficient for A times your coefficient for B, is going to be mathematically identical to C minus C prime. They're the same number, right? What's nice about thinking about this as an indirect effect, as opposed to a mediation or partial mediation in the classic sense is now I can start to, CJ, if I go through and let's say I add in 2 or 3 more mediating variables in this, right? Now all of a sudden sort of this reduction from C to C prime starts to get a little bit more difficult. So I know that when I control for all of this stuff, C goes away, but I don't really know what exactly that's attributable to, right? And so if I'm thinking about this, instead of a reduction from C to C prime, if I'm thinking about the product of AB times as an indirect path, I can go through and test the indirect path for lots of different potential mediators. Some are going to turn out, some of them probably aren't, right? And so mathematically, sort of our traditional thing about the reduction of C to C prime is identical to just thinking alternatively about this as an indirect path, the product of path A and path B. Okay. And then within simple mediation, if I'm thinking about sort of calculating this effect, my total effect here of X on Y is going to be equal to my AB path plus C prime. If I add those 3 coefficients together, I'm going to get back to C. Okay. Pretty simple stuff, but are people seeing kind of how all this ties together? Okay. So I've gone through and I've either calculated C minus C prime, the reduction in my path here, or calculated A times B, the indirect path. They're the same number, it doesn't matter, right? But now my question is, how do I go through and I determine whether or not this indirect path is statistically different than 0? Okay, I want some sort of test of this. Well, if I want any type of test, what I need is a standard a standard error of that mediated effect. And from a classic standpoint, how we go through and derive a standard error for our test statistic of C minus C prime. Sobel provides a formula, actually pretty straightforward. What I do is I take the square of my B path and multiply that by the square of my standard error for A. And then I add that to the product of the square of my A path times the square of my standard error for B, plus the square of my standard error for A, standard error for B, and that gives me an approximate standard error for C minus C prime, or A times B. Okay, and then what I do is I can test I can run an inference test on a z-scale. If I take my indirect estimate of my indirect effect, A times B, divided by my Sobel standard error, this is going to give me a z-score, and then I can use that z-score as a test of my indirect effect. Yeah. And then what I can also do, and I think this is good, McKinnon and Dwyer suggest quantifying the magnitude of that mediation as a percentage of the total effect. So if I take AB divided by AB plus C prime, this gives me a decimal that I can interpret as, of the total association between X and Y, what percentage of that total association is accounted for by the indirect path through my mediator here. Questions about this? Okay. Let's run through a conceptual example here, or sort of an applied example. So what we've got is, my question is, and sort of this is actually from a real paper, do attitudes towards support utilization account for the relationship between PTSD and social support? Okay, we know that PTSD and social support are associated, but we've got sort of this construct saying that, you know, what also matters is people's approach towards support networks. Okay, Sean, you can have all the support in the universe, but if you feel that support networks are untrustworthy and not useful, and you're wary about those support networks anyway, does it matter how many support people you have around you? Probably not, right? I got to utilize it in order for it to be effective, right? I can have all the exercise equipment in my house, but if I don't use it, it's not going to be effective, right? So the question here is, do people's perceptions of support, and particularly for individuals with PTSD who may have negative bias or sort of negative beliefs about sort of the reliability of others, sort of the intentions of other people, does support utilization account for the negative relation between PTSD and lowered support? Okay, so I've got a support variable, 0 to 7. Higher scores indicate greater perceived support. My utilization variable, sort of whether or not people's attitudes towards support utilization, higher scores indicating more negative perceptions of the utility of support networks. And then a measure of PTSD severity, 0 to 50, with higher scores indicating higher levels of PTSD. Okay. So, and what I want to do is I want to test a mediation model here with these data. So here I've got PTSD, here I've got support, and here's my my utilization variable. Okay. So, Siley, step 1. What do we need to do in step 1 of my mediation here?
Wouldn't you compare X to the mediation variable?
Okay, not yet. What do I do before I can even start talking about mediation? What do I need to establish?
The direct effect?
Yeah, I need to establish that X is in fact related to Y, right? Because if X isn't related to Y, I'm kind of in a pickle because I need to provide some explanation for why I'm talking about a mediated effect for something that doesn't have a relationship to begin with in the first place, right? So first thing I'm doing is I'm regressing perceived support onto PTSD. And Nick, am I getting evidence for a C path here? Yep. And how do you know that?
Just looking at the significance.
Right. So I'm getting a very small p-value, right? Suggesting that here my C path, strong evidence for a C path, right? So yes, in fact, in these data, PTSD is associated with perceived support. Okay. CJ, what's my next step?
Now you look at X and the mediator.
Yeah, want to go through and establish an A path here, right? What I want to do, if my story is that PTSD is has an inverse relation between social support, not because of anything necessarily with PTSD, but because PTSD is associated with greater negative expectations of support utilization, which then drives lower levels of social support, I need to establish an effect here, right? And CJ, am I seeing an effect here in my A path? Yep, I sure am, right? So I'm seeing that my coefficient here, 0.251, is demonstrating that there is an association, at least in these data, I have evidence for an effect between PTSD and my utilization variable. Okay. And then Sean, what's the last thing I need to do here?
Establish that there's a relationship between the mediator and Y.
Yeah. Controlling for what? X, right? And so my third step, what I'm doing is I'm regressing Y onto my mediator and my original predictor here. And what I'm getting is I'm getting two paths out of this. I'm getting my B path, right? So this is giving me my association between support utilization and perceived social support. And Sean, am I getting an effect here?
Yes.
Okay. And so my coefficient negative 0.084, demonstrating that, yep, I have an effect here on this path. And then, Sean, what happens to my C prime path?
It becomes worse, but I guess 0.08, so non-significant.
Yeah, right. And so if I'm looking at this, and again, we sort of traditionally would talk about significance, not significance, right? But that starts to become a little bit tricky because what happens sometimes, I can tell you when people are running these models, is I get a C path that has a p-value of 0.049, and then when I account for my mediator, it goes to 0.052, and I complain full mediation because it went from significant to not significant. I would make the argument that your didn't functionally change at all, right? There's just trivial difference here, right? But in this case, we've got something that started out as very clear evidence of an association here. Once we account for support utilization, this is now sort of at best questionable, but it really no clear evidence for a remaining association once we account for this variable. So from a classic Judd and Kenny approach, what would I do with what would I conclude based on these analyses?
You can claim full mediation.
Yeah, I would claim full mediation here, right? But probably what we want to do is we want to go through and have a specific test of this indirect path of AB, right? I have a pretty good idea how that's going to turn out, but what I can do is I can use my Sobel test to go through and actually see whether or not I've got evidence for that indirect effect. Okay. So what I'm going to do, and so this is just sort of my A path, my standard error for A, B path, standard error for B. What I can do is I can just derive a standard error for my indirect effect of AB. And if I do that, if I plug in sort of the square of my B path times my standard error of A path, standard error of B, standard error of A, standard error of B, go through and run this out, I get a standard error estimate of 0.003. And then all I need to do to calculate my z-score is I take my AB path, which is just A times B here, divide that by my my standard error that I derived. I get a z-score of 7.03, a very, very, very small p-value. S is big, Bayes factor is huge, right? And so, Chris M., what am I going to conclude based on these results?
Your results further support a full mediation model.
Yeah, right. So, or at least what I would say, as I probably wouldn't get into full mediation, what I would just say is I have evidence for an indirect effect of PTSD on perceived support through perceptions of support utilization. Okay. So, and so just as if we go back up here, if I go, whoops. All right. Just as a demonstration here, okay? So if I go through and I well, let's try this. There we go. Nope, I can't do that. I need this. All right. So we had said that A times B is equal to C minus C prime, right? Let's see. So what's Alicia, what's my A path here?
The 2.51.
Yep, 251 times, what's my B path?
Negative 0.084.
Someone run that out and tell me what we get.
Negative 0.021.
Okay. And what if, CJ, I didn't see you, but I heard you. What's my C path?
Same.
No. What's the coefficient for my C path here?
Negative 0.03.
030 minus what's my C prime path?
Negative 0.009.
0.009, right? And someone take 0.030 minus 0.009. What do we get?
Negative 0.021.
0.021, right? So this is the thing. This reduction from C to C prime is the same thing as the indirect path. We tend to, from a classic standpoint, talk about the reduction from C to C prime, but it's the same thing as this indirect path. talking about things in terms of an indirect association is going to be much easier to talk about and sort of gives you more flexibility in how you approach this than talking about reductions from C to C prime. Okay. And so what I would do with these analyses is I would say what I have here is I found an indirect effect of of PTSD on perceived support through support utilization. My indirect effect was equal to my coefficient was equal to negative 0.021. And when I ran sort of my test of this, I find convincing evidence in support of an indirect effect of X on Y through M here. Okay. Does that make sense in terms of how we would go through and run that model? Who's more excited about this than mediation or moderation? Yeah.
But it just had a lot of,
Yeah. There's for sure a lot of steps with stuff. Okay. Any questions about just sort of the conceptually what we're going through and doing with that classic causal steps approach?
So Josh?
Yeah.
It seems like your example you could have modeled with moderation or mediation. Do you just use theory to select?
Yeah, right. So you could make an argument that really what it is attitudes towards support utilization isn't the mechanism, it's something that moderates that. But what I would do, and so this is coming from theory and my own research, I would say, well, what I know is that individuals with who have chronic symptoms of post-traumatic stress disorder tend to show lower levels of perceived support than sort of people who don't, right? And I also know that part of the at least in theory, in terms of part of the development of symptomatology, why some people are resilient and some people aren't, is this idea that this thing has happened to me that's changed how I look at the world, how I view the world, how I view myself, right? And so I used to think about the world as safe and predictable, but this thing has happened to me and now it's not. I never know what's going to happen. I don't know who I can trust. I can't trust me. And so it sort of makes sense that if that's my approach to the world, that I might have systematically worse beliefs about the utility of relying on other people. And if I'm not willing to utilize or rely on other people, then it makes sense that my support would be low. And so what I would do and did in this paper is sort of make this causal argument that, yes, this within this model, this makes sense that beliefs about support utilization probably aren't something that just happen randomly, right? It's probably something that's directly related and caused by sort of this symptoms of systematically a result of my symptoms of PTSD. And this specifically is why we're seeing sort of X post-trauma symptoms associated with reductions. Okay. Now there could be an argument for a moderator, but that just kind of makes some more sense, at least in terms of what's going on with these data. And so the paper that I wrote, Chris C, for that paper, that was all cross-sectional data, right? Now it was a sort of the gold standard assessments for PTSD and other types of things, right? And so could make the argument that sort of this theoretically is why, even though we're testing it in a cross-sectional data, this is why this model makes some sense, providing convincing argument for why X causes our mediator, which then causes Y. But if I wasn't able to go through and make those arguments cleanly, and if it didn't make sense within theory, and we could just jumble everything up and around, then it would be harder to sort of get that as something that would be convincing. Right? So yeah, it would always be nice if we had longitudinal data with this measured in this and something happened in between. But in the real world, particularly in clinical stuff, that's not always possible. So I would make an argument that sort of evaluating this in, as long as it makes theoretical and conceptual sense, that these cross-sectional analyses have value, as long as you can give me a good argument for why the model is set up with this way and why I can't just switch everything around, and that model also makes equally good sense with stuff. Other questions? Okay, cool. Let's take a break, and when we come back, we'll finish up with mediation stuff. All right, cool. Right, let's go through, finish up with last stuff here on limitations of the causal effect approach. And so what we'll see is this has been the Barron and Kinney approach has been, or was for a considerable period of time, generally considered best practice approach to going through and evaluating some of these mediation hypotheses. But the approach, like anything else, is going to have some limitations, right? And one of the big limitations, and this was probably Barron and Kinney's approach by calling it the causal effects approach, is that causal steps approach is not sufficient to draw strong conclusions regarding causal problems, causal processes, right? What we would see if we were to have experimental designs, right? Experimental designs are going to give us a much more rigorous test of mediation, right? So if I'm an experimental person, if I'm CJ, and I say, okay, what I'm going to do is I'm going to bring people into the lab, and I'm going to sort of manipulate, randomly assign people to this condition or this condition, exhibit this manipulation. That's a much stronger way to test a mediated effect, right? And this is a thing, God bless you guys in experimental, right? Not only do you have to do one thing to be able to show that you can create an effect, then you have to, sometimes people will make you go through and do stuff to make it go away. It's a whole big, it's nice in terms of strength of evidence, right? But I sort of, yes, no, sort of back and forth, got to go through and do it, right? And so if we were running these mediation little types of studies within the context of experimental designs, we can control for external factors, manipulate this hypothesized mediator. If the mediator is there, I should see an effect. If take the mediator away, it shouldn't be there. A much better way of probably going through and setting things up, right? So if I'm looking at just straight up correlational designs, this is hard. Now, some things I can't manipulate PTSD, right? Chris M shouldn't manipulate an eating disorder in anybody, right? Nick, you should not sort of induce a substance or a sleep disorder on anybody just to see as a test of any type of thing, right? So this idea of establishing causation with correlational designs is much, much more difficult. Many people would say impossible, in fact. Anytime you say the word cause, people start to get really up in arms, particularly like people within even from experimental traditions will get really, really upset if you utter the word cause, right? But if we're looking at things like econometrics, right, like econ and stuff like that, the whole thing is identifying causal effects, right? And so it's a different sort of language approach, but for the types of stuff that we do, what we can do is we can start to institute longitudinal assessment, right? And then I can start to maybe make a stronger argument for at least the conceptualization that, yes, X holds a predictive association with my mediator, which then holds a predictive association with my outcome that's happening down the road, right? But even within that, even a prospective association, sort of temporally, I'm saying that this predicts this at a later time, that's not sufficient to sort of conclude a causal relationship. Lots of things are predicted to later things, but not because they cause them, but just because they do, right? And so what we should probably think about, and sort of this, Chris C, gets to your question about running these types of analyses in cross-sectional data, probably thinking about these as sort of maybe useful determining sort of the plausibility of mediational pathways or indirect effects, but be very, very careful about sort of claims about causality. I would actually never even try and publish anything where I said something caused something else, right? I talk about these as indirect effects and intervening variables. If you say the word mediator, someone's going to get up in arms about and accuse you of trying to claim causality, which technically that's what a mediator means. I call them indirect effects and intervening variables. It's a semantics issue, but it makes people less upset sometimes. So think about, it's called causal models, but it certainly doesn't do anything to establish causality, particularly within our correlational designs. We also have this, so people understand why causal effects doesn't mean we're actually establishing causal associations. we also have this issue with the requirement of some non-zero evidence of a non-zero relation between x and y. Okay, conceptually this makes sense. If I say I found a mediator of the association between x and y, Alicia, did x and y have some sort of association?
Yes.
Yeah. Otherwise, I'm reporting a mediation of something that's sort of not a non-effect, right? Starts to become hard to argue for. But there are situations where conceptually and mathematically, we may not see an effect there to be mediated to begin with, so that it's hard sometimes to detect that effect of x on y. So if I'm correlating x or if I'm looking at x and y, these measurements are occurring relatively close in time, then I probably absolutely should see an association between x and y, right? If I've measured these things in cross-sectional data, or I've measured these things very close in time, I probably need to see an association between x and y, right? But as I start to, and as I probably should with these analyses, right? Sort of this idea of longitudinal prospective data helps me establish sort of that I measured this at this time and I measured this at this other time, and so this still predicts that outcome, right? But what happens as our causal processes and our assessments become more and more distal, what we see is that association between x and y starts to get sort of weaker and weaker because of other stuff, CJ. So if I have multiple mediators start to come through, that can start to attenuate that effect. If I've got other competing influences, right, I've got different types of moderating effects going on. As I start to go through, my error might start to increase. And so if I'm measuring things longitudinally, right, if I'm looking at true prospective relations, I might find that x and that y, if I measured them sort of within close in time, they're associated. But if I start to stretch that out, that effect's still there. It's just kind of hidden by passage of time. Okay. Someone having a question? Oh, okay. And sometimes what I might find is my ability to test distal causal processes or indirect effects it can, in certain situations, start to become easier to detect the indirect effect than it is to detect the direct effect. Okay, so let's say I have a case where paths A and B are consistent with medium effects. So we'll just think about these in terms of correlations, right? So the correlation between my x and my mediator is 0.3, and the correlation between and the unique effect of my mediator and my outcome is 0.3. Okay, and let's say that this is 100% mediation. Okay, that all of the association between x and y is is attributable to this mediator. Okay, well, to test my path of A and my path of B, if I have an effect of 0.3, I need about 80 people to adequately power that detection of my mediational paths. Okay, but assuming 100% mediation, if the total effect of C, if my C path is completely due to my indirect effect, the bivariate association of x on y is going to be 0.09. How did I get that?
Multiply the 0.3 by 0.3.
Yeah, exactly. Right. If my total effect is A times B plus C prime, and A times B completely accounts for the association of x and y if C prime is 0, then that means my xy path is 0.09, right? And so to power my study to detect a correlation of 0.09, I need close to 1,000 people to detect that, right? And so what I can find is I can detect A, I can detect B, but I don't have enough power to detect that base relationship to begin with, right? So this idea that in order to test an intervening variable model, that I need to see an effect of x on y to begin with before I can move forward, starts to become problematic for certain types, under certain conditions. Does this make some sense? Okay. I also have a mathematical issue going on here. Shrout and Bolger note that we can have suppression effects. And what can happen if my AB path has an indirect effect that's equal in magnitude but off in the opposite direction as my residual effect, what I can have is situations where things cancel each other out. So let's say I'm running a model where coping behavior is my mediator, is activated by environmental stress, which is my X, which is then expected to hold a positive association with Y. Okay, so my association between X, which is environmental stress, and psychological distress is positive. Okay, so as my environmental stress, X, goes up, tomorrow what happens to my psychological distress?
It goes down.
As my environmental stress goes up, what happens to my psychological distress?
It goes up.
Okay, right? Alicia, if I'm talking about daily hassles, as daily hassles go up, what happens to my distress?
It also goes up.
It also goes up. So our C path here is positive, right? But if I have an association between environmental stress and coping is going to be positive, as my stress goes up, what does my coping response do? Have to activate that. It goes up, right? But as my coping goes up, what happens to my psychological distress? It goes down, right? And so what can happen is my indirect path here, my AB path, is going to be a negative value. So I've got a positive relation and a negative relation. So AB is going to be negative, okay? But because my total effect of X on Y is AB plus C prime, right? If my indirect path is offset by a residual C prime here that's positive, right? Because this is positive, as my environmental stress goes up, my psychological distress goes up. And if I account for this indirect path here, which is negative, and so I still have a residual positive path, what ends up happening is this C variable, or this C path, is functionally equal to 0, right? So I've basically got the indirect path, and I've got an indirect path that offsets my residual C path. And so it ends up, when I just look at the bivariate association here, CJ, in a bivariate correlation, what's the correlation between X and Y under this scenario?
Positive.
Well, if my residual path between stress and environmental stress and distress is positive, but my indirect path is negative, and AB is about the same magnitude as C, what happens? What's my observed correlation between X and Y?
Small.
Or 0,
Oh, yeah.
right? And so what we can have is certain situations I could fail to detect an association between X and Y, not because X and Y aren't related to one another. I just have an indirect path that's offsetting the residual path, and everything sort of washes out in terms of that bivariate relation. Okay, so the suppressor effects talked about or addressed by Shrout and Bolger, different than suppression effects talked about in Tabachik and Padel. So just want to make sure that you're clear, but functionally what we can have is our math working against us in this situation. Okay. So in terms of our a priori effects, do I need to see an association between X and Y before I can move forward with these analyses? If I'm seeing one, my life gets a lot easier. If I have a base relation between X and Y, it makes me arguing for a model that might already be difficult to argue for. It makes it easier if I can say, yeah, X and Y are related to begin with. Okay, but we might start to relax these situations under conditions where, one, maybe I have clear evidence that X and Y are related. Okay, so Nick, what's reductions in sleep associated with?
Lots of things. I guess we can tie it to substance use too.
Okay, so reductions in sleep associated. Okay, right. So, okay, this is good. Caffeine use and sleeping and hours of sleep, right? If you find in your study that caffeine use doesn't hold a strong association with reductions in sleep, does that mean that caffeine and sleep aren't associated with one another? No, right? Probably not. It just means your sample's small or something happened, you didn't quite detect an effect that you would expect it to. But if there's lots and lots of research out there that says A and B are related, your study probably doesn't trump sort of decades of research saying that it is, right? So in that situation, we might make an argument that, well, it didn't come up we didn't have strong evidence for this in this data set, but we know that in the population, these two things are related, right? So that's one thing we can do. If I'm looking at something, if I'm looking at longitudinal designs where I've measured X and Y, very distant in time apart from one another, I might start to make an argument for, well, we didn't find this base relation, but I'm still going to move forward because there's stuff going on here. Okay, or if I have a potential for a suppressor effect, if my indirect effect is of the opposite sign and of equal magnitude as C prime, well, then I might make an argument that what I've actually got here is a suppressor effect, and that's why I'm not actually seeing this association to begin with. Okay, but again, this requires you to make a reasonable and sort of clear conceptual argument for if you don't see this association between X and Y, again, your life's going to be a lot easier. But if you don't, making arguments for why we didn't see that exactly. Okay. Questions? Okay. Another issue with causal approach, causal steps method, and this is the one that's probably gotten the most, sort of, at least in the methodological literature, the most traction or the most sort of attention. Classic approach with our Sobel's or Sobel standard error of our mediator effect doesn't provide an appropriate standard error for the indirect effect. Okay. What we see is the sampling distribution of my indirect effect is not normal. Okay. If I were to go through and look at the indirect effect, so I've got a sample of 100 people, and I test the path AB, right? And I calculate that. And then I replicate that study 1,000 times over. I'm going to get a sampling distribution of AB. And what we know mathematically is the sampling distribution of AB is not normal. Okay, but the standard error estimate that we get from Sobel assumes a normal distribution of our underlying coefficient. So Ignacio, if I've derived a standard error that assumes a normal distribution of my coefficient, but the sampling distribution of my coefficient is not in fact normal, what happens?
Well, this test is not going to work.
Well,
and your assertion is going to be wrong.
Exactly. Okay. So my assumption isn't exactly correct. The test might kind of get at it, but it's an approximation, right? It's not an exact test. My standard error isn't a good measure of the sampling distribution, which starts to become problematic. So if I have a positive indirect effect, the sampling distribution of AB is going to have a positive skew. If I have a negative indirect effect, the sampling distribution of AB is going to have a negative skew. Okay. So what we've got is we've derived a standard error that assumes a normal distribution, sampling distribution of AB, but AB doesn't have a normal sampling distribution. And so what ends up happening is we see systematically that Sobel produce underpowered tests with inflated type 2 error. Chris M., what happens if I have inflated type 2 error?
Then you're more likely to reject null hypothesis when you're not going to be able to detect effects.
Yeah. I'm missing stuff that I should be detecting, right? I'm too often rejecting or failing to reject the null hypotheses. The effect's there, I just didn't detect it, right? And so for the types of stuff that we do, particularly because type 2 error is rampant in our field, we're kind of concerned about this, right? And so with our traditional Sobel approach, we're worried about not having sufficient power unless our samples are very, very large, unless our effect sizes are very, very large. Okay. Now, are our indirect effects very, very large? Not often, right? Generally, again, in psychology, we should always be assuming, probably absent any additional evidence, that our effects that we're attempting to detect are pretty small. And so unless we have very, very large effect sizes, what Sobel is going to do is probably systematically lowball us. Okay. Questions about this? Okay. So we've seen some variance on Sobel tests, but continues to be pretty limited with things. Okay. So what we also know is that even if we're not using a formal test or a formal hypotheses test, if we're just calculating confidence intervals for our indirect effect using Sobel, those are also not performing real well, as not performing super well, similar to our test of significance, our hypotheses test, our inference test, which makes some sense because it's all using the same information. Okay. So what we've done, and so this has over the past couple of decades started to become, when with McKinnon and Dwyer, what is that? That's a 2002 paper, 98 something. With the advent of computing power, we've started to develop more sort of ready remedies for addressing this. And one of the ways we can address sort of problems with the Sobel test is with bootstrapped resampling. Okay, with a bootstrap procedure, what I'm going to do is I'm going to generate an actual empirical distribution of my estimated parameter. Okay, so what we can do then, so my problem with Sobel is that I'm assuming a normal distribution of my a normal sampling distribution, but the sampling distribution I'm getting is actually skewed. So the distribution I'm using to get my standard error isn't correct. It doesn't fit to the to what I'm actually getting with the effect. But with bootstrapping, what I'm going to do is I'm going to create my own distribution, an empirical distribution based on the data that I've had, and then create my some confidence intervals from there. Okay. So what I do when I'm running a bootstrapping procedure, I use my observed data set. Let's say I've got 200 people in my set. I use those 200 individuals as my population. And what I do is I select a random sample of 200 cases from my set of 200 individuals. I randomly draw 200 individuals with replacement. Okay? Sean, why is that with replacement piece important?
Otherwise, you'd have the exact same.
Yeah. I'm just like sort of I'm just running my same sample over and over and over again, right? But with replacement, so I've got 200 people in my set, but I draw samples of 200 with replacement. And so if I do that over and over and over again, my samples are all going to be a little bit different. Some are going to be a lot different, right? Because the same people are going to get captured in there. But what I'm going to do is if I go through and I calculate that first bootstrap sample, and I calculate my estimate of my indirect effect for that bootstrap sample, and then I do that over, say, 500 replications, or 5,000 replications. So over what I've done with my original set of 200 people, I've calculated 5,000 samples of 200 with the replacement, and for each one of those 5,000 samples, I've calculated AB. Okay. So Ignacio, how many estimates of AB do I have?
You said how many replications did you do in the bootstrap? 5,000?
Yep. So what I have is 5,000.
5,000, yes. So
yep.
In total, you will have 5,200?
Yep. 5,000 samples, or 5,000 estimates of AB with that sample of 200. So what I do is I get a distribution of those, a frequency distribution of my effects. And so when I do that, and I do that 5,000 times, what I can do is then use that distribution, that bootstrap distribution that I've obtained, and then I can use that to get appropriate standard errors and confidence intervals. Okay? Remember, this is going back to first semester, all the way back to the beginning. My standard deviation on my sampling distribution is just my standard error, right? And so what I can do with different techniques, and there are different bootstrapping procedures that are used, what I can do is use that distribution of replicated coefficients from my original set, and I can create confidence intervals and standard errors using those data. Now, because I've got a skewed distribution, my confidence bounds are not going to be symmetrical, right? My point estimate's not always going to fall necessarily dead center in the middle of that estimate, right? But what I can do is do a much better job of getting a getting a sense for what that sampling distribution looks like, and and calculate appropriate standard errors and confidence intervals from that. Okay, so as I said, lots of different bootstrapped confidence interval methods in the existing literature. If you've got a pretty good effect, sort of differences, whether or not you're using sort of this one or that one, probably going to be pretty minor. Process. Hayes is now, looks like in this most recent version process, he's using percentile bootstrapped confidence intervals as the default. They're bias corrected, accelerated. That stuff should be pretty minimal. There's some evidence in simulation data of one working a little, some having certain properties that are better than the other. But again, at the end of the data, if your effect is sort of weak enough, or the evidence is weak enough for different bootstrap methods to start to make those appear or not appear, you've probably got bigger issues than sort of this the effect that you're trying to detect. Okay.
Josh, I have a quick question.
Yeah.
So this is probably going to sound silly, but if you have a sample of 200, you're just taking that sample of 200. Mm-hmm. 5,000 times. How is the data changing any?
Yeah. Sean, why is the data changing?
Because you put it back in the sample again, so it can be picked again. Yeah. So you're not going to get the exact distribution every time.
Right. So PSYC is a member of my sample of 200, right? Now, across any individual bootstrapped sample, PSYC might be in there once, she might be there twice, she might be in there 50 times, she might never be in there, right? Because I pull PSYC and then put her data back in, and she can kept getting pulled again and again and again. And so what we end up with is an estimate of AB that's going to be a little bit different. Some of them are going to be a lot different depending on the nature of the sample. But what I've done is now I've got a distribution that falls along, and I can use to calculate my effects there. Okay. So bootstrapping is a hard thing to do. Tomorrow, do you have time to sit down and sort of create 5,000 replications of a sample by hand?
I wish.
You wish, right? But we don't, right? But what we've done, and Andrew Hayes has done a really nice job of putting together a tool that starts to automate this within SPSS. And what's nice is it ends up being pretty easy and straightforward to run these types of models. We'll pull up the syntax file that goes through and actually runs this. But to run this model, all you need to do is enter in SPSS once you've uploaded the macro is this command here. So it's process y equals whatever your outcome variable is, x equals whatever your x variable is, m equals whatever your mediator is. We're going to ask for total effects here. Model, this is important. Model 4 is a test of your simple mediation. Okay, there are lots and lots and lots and lots and lots of different models that you can run. There are moderation models. There are there's a whole variety of different models that you can run. We're going to be just concerned with model 4 because model 4 is just our mediation. And then here I'm going to request that the output give me the Sobel test for this as well. Okay. Here, lots of other options we can use. I can specify how many bootstrap samples. Default is 500, but if I wanted to put 1 million, SPSS would probably have to work at that for a while, but it would get it done eventually. Confidence bounds, default is 95% confidence intervals, but I can switch that around. This gives me total effects, which starts to become important if I've got multiple mediators in my model. This gives me my normal theory. This gives me effect sizes. This is a big issue in indirect effects, sort of whether or not effect sizes are meaningful or not. I'm not putting them in here because there's like 7 different ones and questions about whether any of them are very good, but something that you can request. Here's contrasts. So again, CJ, if I had, let's say I'm testing a model with 3 different mediators, right? What this will do is give me a test of whether or not the indirect path for mediated 1 is different than the indirect path for mediated 2, and whether 2 is different than the indirect for 3, and whether 1 is 3. It'll give me a formal test of sort of the strength of those individual tests, right? So I can say, yeah, I have evidence of indirect effects for all 3 of my mediators, but 3 looks to be bigger than 2 and 1, something along those lines. And then I can enter center equals 1, and this just goes through and centers stuff for me here. Okay. So what does this look like when I go through and run this? This here on the side, not this. This is what we ran sort of in our regular regression model. But here over on the left, this is my output, what my output looks like in process. So here's the model that I ran, and this is my output. So at the top, I'm seeing process is estimating model 4. My y is my support variable. My x variable is PTSD. M is utilization. Okay. And then what it does is it gives me, if you go down through and you take a look, here my outcome variable is utilization, and my predictor is PTSD. This is giving my test of path A, my first leg, right? This is regressing my mediator onto my outcome or onto my predictor. Okay, and I see within this I get an effect of 0.25 or 0.2509. Yeah. What is this? I got this. Oh, yeah. I got this messed around. Dang it. Just kidding. I'm going to edit that out. Oh. Okay. Oh no. Did the wrong one. There we go. Okay. Now we're right. Okay, so here, my path A, looking at the regression of utilization on PTSD, gives me a value of 0.251. This is the same thing we identified in our model that we ran by hand. Here, I'm regressing support, my outcome, onto PTSD and my mediator, giving me values of 0.009, 0.084, identical to what we've got here, right? Here, we've got my regression of support onto PTSD. This is my path C, and I've got a coefficient 0.030, same thing here. The thing that I want to impress upon you is that this part of what process is doing is not any different than what we did by hand. It's all the exact same thing, okay? And this is one of the things, sometimes you run into, I'm increasingly running into problems where people will say, well, you didn't use process. Well, process isn't doing anything magic in terms of these individual regressions. All process is doing is it's running the OLS regression here, okay? But what you can do is you can go through and see that these models here are giving us exactly what we would expect, or sort of the same thing that we got with our individual regression models. What process does do that's very, very slick is what it'll do is it gives me at the bottom here an effect of the total direct and indirect effects of x on y. So here's my total effect of x on y. This is just my path C, okay? And we would have got this and we got that here, right? And then it gives me my C prime path. This is my direct effect of x on y after I account for my mediator, 0.009. It's the same thing we got here, right? But what process does is it will give me my indirect effect on y plus my percentile bootstrap here, okay? So here's my indirect effect. A times B, this is my coefficient, 0.021. We calculated that, right? But what process is giving me is giving me a lower limit and an upper limit for my confidence bound for the indirect effect of PTSD on support through perceptions of or attitudes towards utilization. And Chris C., what does this confidence interval tell me?
For the boot LLCI and the boot ULCI?
Yeah.
That your A times B is between negative 0.028 and negative 0.015.
Yep. And so based on this, do I have evidence of an effect?
It seems likely that it's not 0, since 0 isn't captured in the confidence interval.
Yeah. And so it starts to become difficult. Remember that we're looking at multiplicative effects here, right? And so we probably shouldn't get too hung up on the magnitude of these effects right here. But this is giving me pretty reasonable evidence that, yes, I'm seeing evidence for an indirect effect of X on Y through M based on this confidence bound, right? And so if we go down here and take a look, because I requested normal theory tests, this is giving my Sobel. So this is my indirect effect, which is the same. Here's my Sobel standard error. Here's my z-score. Here's my p-value, right? But this normal theory test, we don't really need to worry about it, because what we have here is this percentile bootstrapped indirect effect, which is a better way of going out and testing this than our normal theory Z stuff. Do people see what we did here and what process, how we ran process with this? Okay, let me show you quickly what this looks like, because it can be, people have that process macro open and data open. So what I've got here is my support variable, my utilization variable, my PTSD variable, okay? And if I open this process file, there's a lot of stuff going on here. Ignacio, are you interested in going through and modifying that syntax file?
Today, no.
Okay, good. The answer should be never, but the good thing is you don't have to modify anything. With the syntax that I gave you, all you need to do is highlight this command, and you can hit Control A because you don't have anything else going on in there. But all you need to do to run this macro is just highlight all this stuff that Hayes and his graduate students have put together. And you're just running the whole thing. The suspense is killing me here.
Quick question, Josh.
Yeah.
How do we do this in Stata?
There's not a macro for Stata, so if you're going to do this, I mean, you can set up those models to run Bootstrap stuff in Stata. For you, just run the macro in SPSS.
Okay.
Okay, cool. Here's the whole thing, okay? I'm going to go through and I'm going to run that macro, and what it's going to do is it's going to go through and it's going to load that up into SPSS. Okay? And so once I do that, now all I need to do is just enter the model here that I had presented in my data, right? You're just sort of plugging this in. So once I've run my macro, all I do is I write up my command here, make sure to put a period on the end. If I do this and I run it, oh, what is it doing? Okay, well.
I think it's because you have the variable utilize without the E.
Oh, yeah. Good catch, Siley. Let's see if it'll run it this time. There we go. All right. So here's my output, right? Simple as that. So that macro looks super intimidating and confusing. But all you need to do is once you load it up, it's just one command that will go through. And so here's my regression for my A path. Here's my regression for B and C prime. Here's my regression for C. Here are my indirect effects, right? And of this whole thing, okay, the only thing, and Process is an amazing tool, but the only thing that Process is doing is it's giving me, and it's a big thing, is it's giving me this indirect effect right here, okay? This is the thing that's hard to get. I mean, you can program yourself, but it's just a nice, slick tool to be able to go through, and you still need to know what you're doing and why you're doing it, but this will go through and run these bootstrap confidence intervals. And so instead of relying on my Sobel test, now here my effect's pretty big, so it doesn't matter if I run Sobel or not, right? Because this is clearly, I have clear evidence of an indirect effect here, no matter what. But for more subtle effects, this indirect effect here in these bootstrapped confidence intervals provides me a test of whether or not I have evidence for an indirect effect of X on Y through my mediator. Okay? And all I would do is I would report my indirect effect, my bootstrap confidence intervals, and say, yep, I've got evidence of an effect here. Questions? Easy peasy. Who likes this better than moderation? Yeah. it's now if you use Process and so you understand sort of how things are going, you can also run moderation. You can run all sorts of different types of models in there. It's a nice tool, right? But what I want you all to know is what you're doing and why you're doing it. That way you're not just reporting things that don't make any sense and don't realize that they don't make sense. Okay. All right. Last slide here. Let me just finish up. Moderation. So you've got moderation. You know what moderation is. You understand mediation. What you can do is you can start to go through and combine these to go through and start to look at a wide variety of different types of models that start to become really interesting and start to get at more specific and nuanced relationships, right? So what I can do is I can look at moderation with higher order terms, right? I can look at three-way interactions. I can look at quadratic, cubic functions, depending on sort of theory. If I think that there are nonlinearities in my data, I can go through and take a look at those, right? I can look at mediation with covariates, okay? So CJ, let's say that you're not only interested in an indirect effect of things. What you want to do is you want to go through and include a number of covariates in there. We can set that up in Process easily, right? So you're saying controlling for A, B, and C, do I still see an indirect path of X on Y through M, right? We can go through, we can include multiple mediators, right? So here I know that X is related to Y, but I think there's maybe 4 or 5 different processes by which, at least my theory, my conceptual model says that there's maybe 3 or 4 different things that are causing or contributing to this association. I can easily set those up again in Process, test each one of these indirect effects with bootstrap confidence intervals, and then even start to compare sort of various indirect effects with one another. Then I can start crossing moderation and mediation. I could ask, and so in sort of traditional classic way, we talk about moderated mediation and mediated moderation. Within that framework, moderated mediation would be a test of whether or not the indirect effect of X on Y through M depends on the magnitude of some external variable, right? So the indirect effect of PTSD on social support through support utilization differs for men and women, or it differs for people who have experienced sexual trauma versus not sexual trauma, right? We're saying the strength of that indirect effect changes. Mediated moderation says that the conditional effect of X on Y as a function of M is produced through some other different pathway. Basically, my interaction term is mediated. Now, Hayes will make an argument, and I think it's a very good argument, that moderated mediation and mediated moderation are mathematically interchangeable. There's not a distinction. And so how Hayes presents this is talking about these as conditional indirect effects, okay, which is what is he talking? Conditional process analyses, right? And if you want to go through and have questions, there's resources I can direct you to start understanding what's kind of going on with these effects. But if you know the basics of mediation and you know the basics of moderation conceptually and kind of what's going on, you can start to go through and blend these to come up with some really cool analyses, so long as you have a good conceptual reason for doing stuff. Okay, and that's the problem, I think, with process, as with any other tool. You get people running with scissors, and I just went through and I took a bunch, Chrissy. I had a data set with like 7 different cross-sectional measures, and I just threw a bunch of crap in there and just to see what happened. And now I have an effect that's less than 0.05, and I want to tell you why it's important when there's no real reason to be doing that in the first place, at least that you can communicate, right? So a conceptual basis is always going to be the most important thing before you start jumping into these models. Okay. So last slide here, just some thoughts in terms of reporting regression analysis stuff for publications and projects and things. Always, always, always please report your means and your standard deviations. Put these in a table. Make sure that you're reporting means and standard deviations. Report correlations. This is important information, right? So I see you have an effect of X on Y, but it would be nice to see sort of in a bivariate sense how your variables are correlated with one another, right? Think about helping the next person down the road as they're going through and trying to plan studies. Reporting your model R-squared. We often aren't worried about this so much in psychological science, but a good thing to report, telling you the adequacy of your overall model. Reporting standardized effect, unstandardized effect, confidence interval for your unstandardized effect. And then in terms of effect size, I had forgotten about this, but sort of I've kind of fallen on this sort of liking our squared semi-partial correlation as a measure of effect, or alternatively F squared. The issue with a partial correlation is nice because it follows benchmarks for small, medium, and large, but your partial correlation is going to be almost the same number as your unstandardized coefficient. They're going to be a little bit different, but if I put a table with my standardized coefficient and then my partial correlation, it's going to look like redundant columns. F squared is a specific effect for the power analysis of a regression. It doesn't have any good interpretive value, but if you're just looking at benchmarks, small, medium, and large, giving someone something that they can then go through and run a power analysis with down the road, that's kind of a nice thing. Squared semi-partial is nice because it's telling you total variability and Y uniquely attributable to X after you account for every other thing, right? So in terms of reporting things down the road, these might be what I would consider in terms of reporting effect sizes. Yeah. All right. That's it. What I will do is I flip-flopped a couple of those slides around. I'll go through and update those slides, get those to you so you have those at your disposal just so that you don't have anything flipped around there. But other than that, I think that should cover things. Okay. Questions about any of these mediational models or sort of game plan moving forward? Okay, cool.
Did you say when you're expecting our problem sets to get back?
Yeah, I'm going to try and get those to you tomorrow.
Okay, cool.
Yeah.
Thank you.
Yeah. So once you have those, you can go through and take a look and sort of work through stuff. So, other questions? Okay. So the problem set, moderation problem set that you're working on right now, let's shoot for, we'll say, Sunday midnight. Just make sure you got your stuff in. Hopefully people will have getting those close to being wrapped up. But if you have questions, let me know. And I'm here available. Zoom chats at 11 o'clock or midnight on Sunday, but let's not assume that I will be. Just go through, work on those, get those out, but let me know if you're on any questions or difficulties. Sound good? Awesome, folks. All right. Hey, thanks a lot. Your troopers, hang in there. One more, we'll work over logistic regression in our last class, and then you can make a determination on whether or not you want to sort of jump on that last set. Okay. Awesome. All right. We'll see you, everyone.